Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve some GATE problems. This question appear in GATE 2022 examinations. In this question it is given that a current of 1 ampere is flowing through a very long solenoid made up of winding density 3000 tons per meter. Meaning we are given that the number of tons per unit length are 3000 tons per meter. So as in shown in figure, a parallel plate capacitor with plate oriented parallel to the solenoid axis and carrying a surface charge density sigma 6 epsilon naught coulomb per meter square is placed at the middle of the solenoid. So what is the momentum density of the electromagnetic field at the midpoint x of the capacitor? And it has to have the form of n into 10 raised to power minus 13 Newton second per meter cube. And we have to find the value of n. See, in this question, we are given two conditions. We are given the solenoid, and we already know that solenoid is basically talking about the magnetic field here. So magnetic field due to solenoid, we can calculate mu naught Ni since we are talking about the inside point, and it is in the z cap direction. Now, if you know about the parallel plate capacitor, one plate carries a charge plus and another one carries a charge minus. And the electric field created by this parallel plate capacitor is from positive to negative charge. So if I take this as a x-axis, so our electric field is going to be, let's say, is in the x cap direction, and it is the electric field which is created by parallel plate capacitor, which is sigma upon epsilon naught. So we are given magnetic field, we are given electric field, and we have to calculate momentum density. So the momentum density P is given by S vector by C square, where S vector is the pointing vector, which is E vector cross P vector by mu naught. So if you wanted to know how this formula of momentum density and pointing vector frames, you can go through this NPTEL lecture in which this formula is derived. So basically it's a formula based question. We know our electric field, magnetic field, we can calculate S vector. We put this S vector inside this P, and this P is the momentum density that we have to calculate. So we started with the calculation of S vector. So we know that E vector and B vector are perpendicular. P is in this direction and E is in this direction. So whenever we calculate E vector dot P, it becomes mod E mod B into sine theta. Sine theta is the angle between E and B, which is 90 degrees. So its quantity is 1. So basically it is mod E mod P by mu naught. So this is the magnitude of pointing vector. So mod E is sigma upon epsilon naught. Sigma is the charge density which is given to us as 6 epsilon naught. Epsilon naught will cancel out. We are left with 6. Magnitude of magnetic field is mu naught Ni and is the number of turns per unit length, which is given to us as 3000. I is the 1 ampere. So we are left with mu naught into 3000. And the S vector is become mu naught into 3000 into 6 by mu naught. So basically it become 18,000, and we have to calculate the P vector, which is mod S vector by C square, which is 18,000 divided by C is the speed, 3 into 10 raised to power 8 square. That become 2000 into 10 raised to power minus 16, or 2 into 10 raised to power minus 13. The unit is Newton second per meter cube. So we have to compare it with the given answer, which is in the form of n into 10 raised to power minus 13. So that means n is 2. So we have to find the value of n, which is 2. So this is the answer for this question.